Hello everyone, it's Benny, and welcome back to the Wolfenstein 3D tutorial. In this video, we're gonna hopefully start finishing up all the various states of our monster. We're gonna implement the idle state, we might implement the deaf and dying state, but we're definitely, at the very least, we're definitely gonna make the player start shooting at the monster so we can have sort of a gunfight between it. And yeah, but first off, I just want to show you something. I actually did this a week ago, so this is kind of old news by now. But if you look, you see, well, it looks a little bit different now. And that's because I'm playing with the free texture. That's right. I put together a very basic, very MS Painty free version of the Wolf Collection texture to hopefully help people who don't have Doom or Wolfenstein on their computer to start, well, actually being able to follow along. It's not complete yet. I've done, I think, 4 textures out of 16, so I'm about 25% done. And I'm going to keep working on this until eventually, hopefully, I can get something that has all the textures that I use, so people who don't have it can follow along just fine. That's the idea anyways. So yeah, I'm actually now going to go ahead and change that back, so one moment. Yeah, probably should have done some of this off-screen, but oh well. So this is the free version, and this is the one that actually comes, well, this one that comes from Doom. Wait, there we go. Okay, great. So now if I run, it should be back to normal. And excellent. Okay. So now what I want to do is I want to implement the idle update state. This is a state where we're going to be, well, we're going to be looking around. We're going to see if we see the player. If not, we're just going to sit there and do nothing. But if we do, that's where things will be a little bit more interesting. So I'm going to start in the idle, the idle state. And what here's how I'm going to do this. First off, I'm going to delete the 10 million spaces I have here for some reason. Oh, okay, it's just the way it works. Never mind. But what I'm going to do is I'm going to have some private boolean can look. And I'm going to start off with can look equal to false. And what we're going to do here is we're going to do two things. First off, we're going to find the current time, which I believe I did somewhere. Did I? No? Okay. Well, never mind then. Okay, I thought I calculated current time somewhere, but apparently not. So, here's what I'm going to do. I'm going to have some double. It's going to be called time. Yeah, time. And this is going to be time.getTime, the whole thing I did before. So it's going to be divided by time.second. And this is the same process I've done every single time now. I've already have a note about how this is big and painful. So cast this to a double, and that should give me the current time. But what I actually am interested in is instead what I'm going to say time decimals, which, well, this is going to be the decimal portion of time. So I'm just going to take time, and what I'm going to do is cast time to an int, and that's going to get rid of all the decimal places, and then cast it back to a double, so it's back to a double. And then I'm just going to take time and subtract it from that. And that should give me the decimal portion of time. You might be wondering, hey Benny, why would you care about the decimal portion of time? And that's just how my timing system is going to work. If time decimals is, I'll start with, less than 0.5, then we're going to do something. And what we're going to do is, actually, and we're going to have an else, because that's going to bother me, because we're going to be doing this, in two parts. We're going to have the if, and, well, of course, we're going to have the if and the else. Surprise, but no. The reason I'm bringing this up is because what we're going to do in one of them is we're going to reset the can look state. And yeah, I'm going to do that here. So can look equals true. Otherwise, in the else state, I need this properly aligned or it's going to bother me. If we can look, then what we're going to do is that big ridiculous check, and then a big ridiculous check I haven't shown you yet, but we're going to do a big ridiculous check, and then from there, we're going to, well, yeah, we're going to see if we see the player, if we're going to change states. And what we're pretty much going to do here is what we've done in the attack state, where we do perform an intersection check. So I'm just going to copy and paste, which, yeah, could probably be put in its own subfunction, but it's too late to save the coding practices of this series so far. So, yeah. So if we can look, and actually, yeah, if we can look, not going to care about the distance, then right here, we're going to, well, first off, I'm going to delete this because I don't need that. Just right here, we're going to, actually, yes, let's print out something, why not? We're going to print line, we've seen the player. And that, well, this should turn true, or this should happen when we actually see the player, when it comes into line of sight. And yeah, there we go. So we've seen the player, but that doesn't mean very much right now, because, whoops. Because our monster is right in front of us. Of course he's going to see us immediately. So let's move the monster a little. Let's make him... Would 9 be out of the level? Let's find out. So let's run, let's see what happens. Oh, he's inside the wall. Okay, let's try 11:11. Oh, did I close that? Okay, good. And let's run now. I'm just playing around to try to get him behind the wall. And, oh! Have we seen the player? No, of course we haven't. Now we have, of course, but... Okay. So let's try 12:12. 12 is a magic number. Come on. And we haven't seen the player. Interesting. Now we've seen the player. But he doesn't see us immediately. Very interesting. So actually, let's remove this can look check for a moment because I want to see something. I want to see if this actually is an issue. Or, well, yeah, if it's actually an issue or not. This might cause horrendous lag, but that's okay. So we should be constantly, yeah. We're constantly checking and we're not seeing. Okay, interesting. So one moment, I'm going to figure out what the issue is off camera. Okay, I have managed to track down the bug. And it's actually two things. First off, you notice right here, we're rotating the angle we're looking in, or the direction we're looking in, by some random amount. And I actually removed something, sorry, I forgot to put that back in. But yeah, point is, we don't want to rotate our cast direction, we just want to look directly towards the player. So, let's get rid of that. But there's actually another much sneakier bug going on here. And that is in our level class, in our check intersections method, where we're looking for doors. Right here, we're checking line intersections with the door positions, and not with the door rectangle. And that's a big problem. So yeah, once you change this to line intersect rect, you should be able to run it, and it should be able to work just fine. If it ever actually loads. There we go, so now he should see us immediately. Yeah. So now, if I change this... Whoops, wrong hotkey. If I change this back to the look system, he should see us within a second. Possibly more, but within a second, at least. Yep, he sees us pretty much immediately. And just one more time for good measure. Just gonna wait a moment now. I'm gonna go for it. And yeah, it takes him a moment. Okay, cool. So we're not just doing this check 10 million times a second. It's done only once a second. So that way, idle monsters don't create this gigantic performance issue. So, yeah. And that's great. So now we've got working idle update. We've got our monster, he can be in the idle state, he can look for the player, but, well, there's the chase state. When he's chasing the player, I don't want it to just be chasing indefinitely. I want him to sometimes, you know, say, hey, you know what, let's shoot the player. Let's gun him down. Let's, you know, do something. So that's going to be our next task. And believe it or not, this is actually going to be pretty easy. First off, our first condition is, if we are within the movement stop distance, then he's not going to be doing anything else, so the only logical thing for him to do is start attacking us. So that's going to be our first case where he can start attacking us. If he's past the movement stop distance, then he's just going to keep gunning and gunning and gunning and gunning and gunning. So, let's see how this works out. Gonna run, and, oh, he's seeing us. He's getting closer. He's approaching, and he's gonna start shooting at us. Oh, snap! He is gunning us down. Yeah, we would be very, very dead if I actually had any damage detection in. That's okay. I'm gonna actually put some sort of time limit on the attack state at some point. Well, later in this video, hopefully. So that we don't actually, you know, just gun him down infinitely. But yeah. So, that's one case. The other case is rand.nextDouble. If that is less than some constant, so just say const value times time.getDelta, then we want to get into state attack. And you might be wondering, well, I can understand if it's less than some constant chance, but why are you bringing delta into this? Well, the reason I'm bringing delta into this is because, and actually I'll go ahead and name this to attack chance, and it's going to be constant, and then I'll go ahead and create it because it's bothering me, and get rid of this because that's bothering me too. But yeah. So public static final float, attack chance, I'll set that to 0.5 times time.getDelta. And you might be wondering, why am I multiplying this times delta? Because I want him to attack roughly the same amount of times per second on average. And that's a good way of ensuring that. This way, if it takes 20 seconds for a frame, then he's going to have a much... Yeah, if it takes 20 seconds to draw a frame, he's going to have a much higher chance of attacking than if, well, we only have, say... we have 1,000 frames a second, you know? This way, the attack chance is frame independent, because you gotta keep in mind, this is being called every single update. And that's just an easy way of making sure that the attack chance is indeed frame independent. So now if I run, we should have him randomly attacking us at some point. Oh, we've seen the player. Oh, we just shot the player. Oh, snap! We're shooting the player. All over the place. Bang. He's aggressive. Oh my. Yeah. Okay. Yeah. Let's go ahead and hide behind this. He is really mad with that gun. Is he just... Dang, why is he... Actually, that's a good point. Why is he just going so crazy with that? Then movements... You know, okay, maybe I shouldn't do this, because that seems to be having some, well, minor interferences. So, yeah, let's comment this out, and let's try again. Okay, so now this time I'm just gonna run straight past him, and we get shot, of course. Yeah, that's weird. Why is he just spamming attack like that? And not, you know, when he's hitting a wall. That actually is a good question. That shouldn't be happening. Okay, and that was actually a lot easier than I thought it would be. We're only going back to the chase state after we hit the player. So if we aren't hitting the player, he's just going to stand there shooting forever until he hits us. And that's not quite what I want. I want him to just try a shot, and if he doesn't hit, he doesn't hit. So, and with that, I think I can actually bring this back in. So let's try that again. Without the ridiculous shoot the wall for eternity nonsense. Oh snap! Yeah, we'd be dead right now, but that's okay. Okay, now I want to see if he actually will chase us through the door and actually shoot through the door. If he hits us, yeah, he shouldn't be shooting us right now. He should be able to... Well, the door should be in the way. Okay, cool. So, shooting through doors doesn't... yeah, doesn't destroy everything just yet. And, well, yeah, so we've got our big fancy make him attack thing working. But now, of course, I don't want him to just shoot instantaneously. I want an attack to have a similar system to the can look system. In fact, I'll rename this to can. You know, fine. I'll have a separate Boolean just because. Why not? Well, okay. Just because I want attack to have some tangible amount of time to it, not just. Wait. No, this dot can attack is false. I want. Yeah, I'm going to do a similar check here, because I want attack to have some tangible amount of time to it, not just shoot and then he can immediately try shooting us again if something doesn't work out. So I'm going to have a check for that. I'm going to do the exact same, whoops, can attack, else, this whole thing's going to be one big gigantic else statement, and can attack is false. So attacking's going to take anywhere from half a second to a full second, depending. So, now he shouldn't be able to spam attacks infinitely. He should be able to have some tangible amount of time to it. So yeah, let's see what happens. If anything. So now he should be you seen us? And if I get right next to him, he's still shooting us a million times. Okay. Maybe it's not quite that simple. Right, because what if he gets here and then... well, yeah, that's going to be a problem. So actually, one moment. I'm going to need sort of weird delay system here. Okay, and actually, the issue was, for some reason, I forgot to check if we can attack. So I'm going to change this to an else if, or I changed this to an else if of whether we can attack or not. And I also did the same thing over here with can look, just because, well, why would I not... why would I have an else just to have a big giant if statement there? So yeah. And now if I run, you should see that the attack is a lot better behaved. So you've seen the player, and if he gets right up next to us, he's going to shoot us, but only once a second. So he's not just going to spam attack forever, just because he's right in front of us. So yeah, there we go. That's much better. So, and with that, I think we're at quite a good place. We've completed the update, the idle update, so he can look for us and see us. We've completed the chase method, so he can chase us, he can do all that. And we've completed the attack. He can attack us, he has proper limitations, and everything. Now we just have two more states, the dying and the dead state, which are going to by far be the easiest states to take care of. So, yeah. So, in order to actually implement these states, I'm actually going to create a new method. It's going to be public, so I'm going to scroll up a bit to right here, and create a method, public void damage, which takes in some amount. That's how we're going to actually hurt the monster. And the monster's, of course, going to have some private int called health, and by default this .health is going to initialize to some max health variable, which is going to be a constant. And there we go, public static final int max health is going to, I'm just going to say it at 100. And you can play around with this and set it to however you like. I'm just going to do basic 0 to 100 health system. And here's how damage is going to work. It's going to affect our state. First off, if our state is idle, then we know someone's shooting at us and we're going to go after them. So if we're in idle when we get hit, whoops, if state is equal to idle, then we're going to start chasing them. That's our first reaction to damage. Secondly, our health is going to be subtract. Of course, our health is going to subtract the amount. And finally, I'm going to check if that is less than or equal to 0. And if it is, then we're going to start dying. No matter where we are, we're just going to start dying if we're less than 0. And that's how we're going to trigger all this. So, there. And in dying update, what we will do eventually is we're going to play the death animation here. while he's still dying. Otherwise, we're just going to say state he just dies immediately. And in the dead update, well, we're actually not going to do anything here. We're going to set our... yeah, we're just going to stay here. That's what we're going to do in the dead state for now. We're eventually going to have... well, I shouldn't say an animation. We're just going to set this to the dead sprite so that we don't change our sprite and whatnot. But, yeah, we're just going to be in the dead state right here forever, once we're in the dead state. But, of course, we don't have any good way of testing this. So, I have a mildly evil way of testing this. I'm going to say, every time we try to open a door, we're going to hurt the monster. Well, every time the player tries to open a door, that is. So, oh right, we don't have a list of monsters. So instead, I'm just going to say monster.damage 30 whenever we hit the E key. And actually, I should probably print something out in the dead state so that we know he's dead. So, yeah. We're dead. Because I don't have an animation to show it just yet. So now if I run... oh, here he is. He's coming after us. I'm going to hit him. 2, 3, ready? Boom. We're dead. And there's our monster just sitting there forever. Not doing anything special. Just, you know, just dead. So excellent. We have damage system, we can hurt, and we can kill the monster. And that is wonderful. Now the only question is, will I have time to make the player shoot the monster in this video? And well, apparently not. I just tried making the player shoot the monster, and it took a whole nother video's length of time. So, unfortunately, I don't have the time to make the player shoot at the monster. But hey, at least now we're finished with the monster's logic, and yeah, so we shouldn't have too much more to do with the monster. So, thank you, hope you enjoyed, hope you learned, and see you next time, where the player is going to destroy the monster with his gun. Thank you, see you next time.